Students, today we are going to discuss about Unit 1, Units and Dimension. Topics cover basic and derived unit, use of different system of units in process calculation. One by one we will discuss. First one, basic and derived units. This is dimension and unit. What is dimension? Basic concepts of physical measurements or physical quantity. Length, time, mass and temperature. Length is denoted as L, time is denoted as T, mass is denoted as capital M, temperature is denoted as theta or capital T. What is unit? Unit or term that precede and describe the dimension. Examples of unit: length unit is meter, time unit is second, mass unit is kg, temperature unit is degree Celsius. Classification of dimensions. Dimension classified into two types. One is fundamental dimension, another one derived dimension. Fundamental dimension is also called basic dimension. What is basic dimension? Dimensions that are measured independently and enough to express essential physical quantity. What are the physical quantity? Length, mass, time and temperature. Derived dimension. What is derived dimension? Dimensions that are product or quotient of fundamental dimension. Another definition of derived dimension: derived dimension derived from fundamental dimension or basic dimension. Example: density. Density unit is kg per meter cube. Kg is the unit of mass, meter is the unit of length. So, derived dimension derived from basic dimension or fundamental dimension. Another example: velocity. The unit of velocity, meter per second. Meter is the length unit, second is the time unit. System of units. What are the system of units? One is the SI unit, International System. Another one, American Engineering System, AE System. First one, SI System, System of International or International System. This is simple system. Fewer name or associated with the dimension. This is the current metal system. American Engineering System, deeply rooted in the United States. Other name of this system are English or US customary or imperial system. SI dimensions and units. SI is nothing but System International or International System. So basic SI unit, what are the physical quantity? Length, mass, time, temperature, molar. Name of unit: length, meter, mass, kilogram, time, second, temperature, Kelvin, molar amount, mole. Symbol of physical quantities: length, m, mass, kg, time, second, temperature, capital K, Kelvin, molar amount, mole. Derived SI unit. So already I said derived units derived from basic unit. Energy, unit of energy, joule, symbol is J. 1 joule is equal to kg meter square per second square or Pascal meter cube. PA is nothing but Pascal. Force unit is Newton. 1 Newton is nothing but capital N. 1 Newton is equal to kg meter per second square or joule per meter. Power unit watt, symbol W. 1 W is equal to kg meter square per second cube or joule per second. Density unit kilogram per cubic meter, that is kg per meter cube. Velocity meter per second. Acceleration meter per second square. Pressure Newton per meter square or Pascal. 1 Pascal is equal to 1 Newton per meter square. This is pressure unit. Heat capacity joule per kg Kelvin. Alternative unit time, minute, hour, day, year. That is, minute is nothing but min, hour h, day d, year is y. Temperature is a degree Celsius. Volume liter or decimeter cube, capital L. Mass unit is gram or kg or ton. This is a mass unit. American Engineering Dimension and units. American Engineering Dimension, another name is a FES unit. FES is nothing but foot per second. Physical quantity, length, mass, time, temperature, molar amount. These are the basic unit. Length unit, foot, ft, mass, pound, lbm, time, second, minute, hour, day. Temperature unit, degree Rankine or degree Fahrenheit, molar amount, pound mole. Derived units, force, pound force, energy, British thermal unit, that is BTU, foot, pound force, lbs. Power, horsepower, HP. Density, pound mass per cubic foot or foot cube. Velocity, foot per second. Acceleration, foot per second square. Pressure unit, pound force per square inch. 1 pound force per inch square is equal to 1 psi. Heat capacity BTU per pound mass per degree Fahrenheit.
Welcome to ProEdify T's Prep. This is part 1 of the lesson on units of measure. In this video, we will discuss various units of measure, and we'll also introduce the SI system of measurement. To begin, let's define what a measurement is and what it actually means to measure something. Well, in science, a measurement is considered the assignment of a numerical value to an object's physical property. Measuring physical properties such as length, volume, and density is very common. For example, you might want to know the length of a line, the volume of a sphere, or the density of a liquid. Whenever we take measurements, we also have to assign units to the numerical quantity in order to convey the relative size or magnitude of the property in question. For instance, if I said the length of my shoe was 10, you wouldn't actually know how long my shoe was because there would be no context for what the 10 represents. In fact, this measure would only make sense if the number 10 had a unit of measure to go along with it. So what is a unit of measure? In order to have accurate and reproducible ways to define magnitudes of length, volume, density, etc., scientists have developed various systems of measure. These systems are made up of units of measure, which are basically standardized amounts of various physical quantities. The SI system is the international system of measure used by scientists. It is a very comprehensive system with many units of measure. However, we will only need to cover a few of these units in order to prepare for the T's. The fundamental physical properties you will need to know for the T's are as follows: mass, length, temperature, and time. You can see that for each property there is a mathematical label which is used in formulas. and the actual name of the corresponding SI unit or measure. Please feel free to pause the video and familiarize yourself with the information on this chart. Notice that the chart refers to these units as base units because they help to define more complex units, which are called derived units. For example, area is a physical property that uses a unit called meters squared. Since meters squared requires the meter in order to be defined, it is considered a derived measure or unit. Let's walk through an example that will illustrate how the meter is actually used to define area in meters squared. If we take a line that is 2 meters in length and then create a square from 4 of these same lines, we can find out the area or two-dimensional space that this square occupies by squaring the length of the original line. We're not going to talk about the math concept of squaring in much detail here, but just know that in essence, we're multiplying a base length measurement by another base length measurement, which is 2 meters times 2 meters. And this results in an entirely new derived unit called meters squared. Now that we understand a little bit about derived units, let's take a look at some important ones that you will need to know for the T's. By looking at this chart, you might have noticed that things like mass per unit volume and meters per second are also considered units of measure, just like the liter or the Newton. The only difference is that some measures, such as liters and newtons, have a unique unit name, while other measures have unit names based on their mathematical formula. Also note that some derived units require other derived units in order to be defined, which is the case with both density and pressure. Now don't worry if you're a little confused about these measurements and what they're used for. We will discuss them in more detail as they are used throughout the series. This concludes our discussion on the SI system of measurement. Thank you for watching.